Assalamualaikum and a very good day to you all. In this video, I would like to share with you some examples of differentiation for trigonometric function. So let's get started with the first example. Okay, so for trigo, we have to find the bracket. The bracket inside sine, cos or tangent function. Okay, so over here the fx is x. So we right away can do the differentiation lah. So dy dx equals, so cosine becomes negative sine. Okay, fx just copy paste x. Okay. And then we multiply by the differentiation of x. So differentiate lah the x. Like this. Okay. And then minus sine x. Differentiation of x is 1. So if we multiply by 1, it's going to be also equal to minus sine x. So this is the answer for the first one. Okay, let's go to the second one. Y equals sine x over 1 minus cos x. Okay, for this one, we have to use quotient rule. Okay, so this one is u. Okay, so u is sine x. Yeah, so u prime. U prime is how to differentiate sine. Differentiate sine is cosine x multiplied by differentiate of the bracket, which is x. So it is equals to just cosine x. Okay, so that is for u. Okay, now how about the denominator v? Okay, so we do it over here. V equals 1 minus cosine x. So v prime is 1 differentiate is 0 minus cosine x. Okay, so the negative we just leave it over here. We differentiate the cosine here. So cosine differentiate, we get minus sine x. Okay, and then we, okay, zoom lah. Multiply by the differentiation of the fx, which is x lah. The function inside sine is x. So differentiate x is 1. Okay, it's just 1. Okay, and then minus sine is sine x itself. So this multiply by 1, no need to write lah. We want to simplify, no need to write. Okay, next what to do? So this is merely the product rule. We haven't write it nicely down here yet. Product pula. This one quotient, sorry. So dy dx. Okay, quotient, what do we need? We need the long line over here, and then down here we need square. In the middle we have minus. So how to do quotient rule? Okay, so we do this. Okay, and then we have to minus them. So what is that? U prime with v. So u prime is cosine x. Okay, v is 1 minus cosine x. Okay, and then minus sine x. Sine x u v prime. Sine x. Okay, and then down here is v lah, because v squared, right? Okay, 1 minus cosine x. Okay, now is the time to simplify lah. Okay, so this one we can expand lah. Cos x minus cosine squared x. And this one is minus sine squared x. Okay, I think we can simplify this further. Okay, 1 minus cos x. Okay, 2. Okay. Now, this minus over here, okay, I highlight. This minus we can factorize. So what we get? Cosine x minus bracket cosine squared x plus sine squared x. Okay, over 1 minus cos x square. Okay, and then tak muat. I do it over here lah. Okay, so cosine minus cosine. Okay, and this one, if I'm not mistaken, by using identity equals to 1. So what we have here, next line, cos x cos x minus 1 over 1 minus cos x squared. I think can cancel lah. Okay, can cancel. Okay, we factorize negative out of them. So what we get? We get 1 minus cos x. 1 minus cos x square down here. Then we can potong this one and this one we can potong. Leave us with minus 1 over 1 minus cos x. Okay. So this one quite long lah. But that's the solution. Okay. So let's go to the next example. Okay. Let's go to the next example. Example 3. Example 3. Y equals cos x power 2. Okay. Okay. Now, for this one, how to differentiate? Okay, remember to highlight the fx inside the bracket. Okay. So this one is x squared. So dy dx is cosine differentiate become negative sine x squared, just copy paste. And then multiply by what? Multiply by the differentiate of the bracket. Okay, differentiate of the bracket x squared. So the differentiation of x squared becomes 2x. Okay, multiply minus sine x squared. Okay, this one you cannot multiply inside here. What we have to do for this one, we have to put it in front. In front over there. It's like a constant lah. Okay, so how to simplify? Minus 2x sine x squared. So this is the answer. Okay, so next example 4. Okay, y equals tangent cube. Tangent cube x over 3. Okay, x over 3. Okay, so for this one, we have a little bit different one lah. Previously, we don't have sine, cos and tangent with a power. So this one we have to rewrite. Rewrite y equals tangent x over 3 bracket of power 3. So this one we have to use what? Power rule. Power rule. So what is power rule? Power rule, okay, dy dx equals what we have to do? The power bring in front, copy paste the bracket, okay, x over 3, and then the power minus by 1. And then we have to do another thing, is that we have to multiply by the differentiation of the bracket, which is tangent x over 3. So as you can see over here, we have 2 layers. The first layer is to differentiate the power rule here. Okay, the second layer is to differentiate the trigo inside here. Okay, so that's why you have to do it very careful, one by one. So that's why I write this differentiation like this. Okay, for you to see it clearly. Okay, so simplify lah. Okay, so this one will be simplified. This one tangent just copy paste, no need to worry with power 2. Now this is our next worry lah. Okay, so how to differentiate this? Okay, so tangent, okay, before that we have to highlight lah what's the fx. This is the fx. So tangent differentiate becomes secant squared. Secant squared x over 3. Like that. And then multiply by the what? By the, I use blue color lah right now. Differentiation of the power pula, bracket, sorry. Okay, which is x over 3. Okay, so we can further simplify. We have 3 tangent x over 3 squared. Okay, sorry, I have to put the square outside another bracket. Like that. Okay, and then secant squared x over 3. So this one no need the multiplication symbol anymore. Just put the sign next to each other like this. Trigo sign like this. Okay, and then multiply by what? X over 3 x over 3 differentiate with respect to x is 1 over 3. But this one cannot multiply inside here, cannot. So you have to multiply over here, over there. So we multiply over there becomes, okay, so 3 multiplied by 1 over 3 is 1. So 1 tangent x over 3 square secant square x over 3. So this is the answer. Okay. Okay. Okay, next. Last one lah, I suppose. Number 5. I forget lah. Number 4. E5 lah. Okay. E5. Y equals 3 sine cube. 3 sine cube. 3 sine squared lah. 3 sine squared. Or cube lah. Cube x squared. Okay. So, how to do this one? This one we have power, right, over here. So, we have to rewrite just like the previous example. So, how to rewrite it properly? So, 3 bracket cube inside got sine x squared. That's better. Okay. Now, so, for this one, we have to use power rule one more time. So, power rule, the fx is this one. Okay. So, let's do the differentiation properly. Okay. So, we have 3 just a constant. Okay, differentiate. Okay, multiply by another 3 that we have from the power here. Okay, so, bring it down. Copy paste everything. Minus 1. Okay, and then this one copy paste also lah. Sine x squared. Okay, and then what's next? The next step for power rule is to differentiate what? Differentiate whatever inside the bracket, which is sine x squared. This one I write it nicely. Later confused. Better. Okay, so this one we can simplify lah. 3 is 9. And then this one, sine x squared. Okay, another square. This one, this square, this outside square cannot go inside here to become x power 4. So please, just leave it like that. Or rather, you can write it like this lah. Sine squared x squared. Like this. Pun boleh. No problem. Okay. So, we need to differentiate this one. How to differentiate this one? Okay, putlah multiply over here. Okay, sine. Sine differentiate to become cosine x squared. Multiply by differentiation of what? Differentiation of this fx. The one inside the bracket. So, x squared. Like that. Okay, so what we get? 9 sine squared x squared cos x squared multiply by 2x. Don't forget, this 2x cannot over here, cannot. We have to do it over here. Multiply way in front over there. So, the final answer is 19x sine squared x squared cosine x squared. Okay, so I think that's all. Thank you for your time and attention. Assalamualaikum. Have a good day.